Okay, so in this segment, we move on to derivatives of some of the other basic trig functions. Okay, so let me give you their definitions first. Secant of x is equal to 1 over the cos of x. Cosecant of x is equal to 1 over the sine of x. Tangent of x is equal to sine of x over cos of x. And cotangent of x is equal to the cosine of x divided by the sine of x, which is equal to 1 over tangent x. If we want their derivatives, then we can calculate some of the derivatives using the reciprocal rule, and we can calculate other derivatives using the quotient rule. Okay, these functions are continuous wherever they're defined. The way we've defined them, they are not one-to-one, onto, or invertible. Okay. Some identities which are used when simplifying results sometimes are cos squared u plus sine squared u equals 1, 1 plus tangent squared u equals secant squared u, and 1 plus cotangent squared u is equal to cosecant squared u. Okay, so let's take the derivative of the secant function. That's the derivative of 1 over cos of x, which is equal to minus the derivative of the cosine of x divided by cos squared x, and the derivative of cosine of x is minus sine of x. The double minus signs cancel, and then you get sine of x over cos squared x, which is equal to sine of x over cos x times 1 over cos x, which is equal to secant x times tangent x. So the derivative of secant of x is secant x tangent x. Okay. As an exercise, you should now show that the derivative with respect to x of cosecant x is minus cosecant of x times cotangent of x. Okay. The derivative of tangent of x is the derivative of this quotient of functions sine of x divided by cosine of x. So that will be cos of x times the derivative of sine x, which is cos x, minus sine of x times the derivative of cos x, which is minus sine of x, divided by cos squared of x. Okay, so the top then is, the numerator is cos squared of x plus sine squared of x over cos squared. But cos squared plus sine squared is equal to 1, so we have 1 over cos squared, which is equal to secant squared of x. So the derivative of the tangent of x is equal to secant squared of x. Okay. Using the same approach, you should show that the derivative of the cotangent of x is equal to minus cosecant squared of x. Yeah. Now let's do an example. The derivative with respect to x of the secant of x squared plus x plus 1. Okay, what's the derivative of secant of x? It's secant of x tangent of x. You have an inner function which is a function of x, so you are going to have to do the chain rule. Okay, so the derivative of the secant of something is secant of something times tangent of something times the derivative of something. The something was x squared plus x plus 1, so times 2x plus 1. Okay. Let's try another one. The derivative with respect to x of sine of 1 plus x squared. So we've got nested functions. So when we take the derivative, we're going to have to work our way in from the outside. So first take the derivative of the outer function. We'll have cosine of sine of 1 plus x squared times the derivative of the middle function, which is cos of 1 plus x squared, times the derivative of the inner function, which is 1 plus twice x. Okay. Now, let's look at this. The limit is x goes to 0 of sine of the sine of 1 plus x squared minus the sine of 1 over x. Okay. We put it into a slightly different form, right? So this is the sine of 1 plus x squared minus the sine of 1 plus 0 squared over x minus 0. What is this? By definition, this is the derivative of the sine of 1 plus x squared when x is equal to 0. So whatever derivative you evaluated for this function, now let x equal 0, and that would be the answer to this problem. Okay. In the next segment, I'm going to reconsider this equation that we saw for simple harmonic motion before, y double prime plus k squared y is equal to 0.